Okay, hi guys. Today we're talking about comparing fractions, and so here is a quick tutorial, just quick reminder about how we do that. Okay, so when we compare fractions, the first thing that I can do is first I can use what we call number sense, and that means that I can look at these two fractions, 1/3 and 7/8, and when I think about those, I know that 7/8 is almost a whole number because we know that 8/8 is the same as 1. So we know that that's almost a whole number, or almost a complete 1, okay? Where we know 1/3 is not, okay? You can also think about it as sizing-wise. You know, like if I had a picture of 1/3, so I'm going to take my whole 1, I'm going to divide it into thirds, and we know that this represents 1/3. But then when I have a fraction of the same size, and we're going to divide it up in 8 parts. So here I'm going to divide it in halves, and then now I've got fourths, and then I know since I'm working with 8s, I'm going to divide each of these into 2 parts again. That way I have 8 total pieces, and so now I have 8s, and I know that 7/8, that means that's 1 and 2, 3, 4, 5, 6, 7, and there's my 7/8. So I can tell by looking at this picture that 7/8 is a much larger fraction, and so I would use the symbol less than. 1/3 is less than 7/8 to describe that comparison. Okay, but this is there's a lot of steps involved here. So like I said, you don't want to draw pictures. That's not always the most efficient method. So when we have two other fractions, though, let's say with these two, I can't necessarily use number sense because these two are pretty close in size. Both of these are almost one whole. And so one way that I can compare fractions, though, is something that we all know more about, which is finding a common denominator. So because once I find that common denominator, then I can look at the size of each one of them and decide which one's larger or smaller. So one thing that I can do to find that common denominator when we have 5/6 and 6/8, one thing that I can do when I'm looking at those two common denominators is we know that one strategy is to multiply them, so I could use 48 as my common denominator. That's one choice. But then I can also, we know that the other method that I can do is I can list multiples of 6 and 8. So let's do that here real fast. Multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 34. Multiples of 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And I don't need to go any further because I see a match. And I can use then 24 as my common denominator. Okay? And so we know that whenever we're doing that, we do the same to the bottom as the top. We do the same to the bottom and the top, I should say. And so we know 6 times 8 is 48, so I do the same to the top. So 40. Here I need to times by 6, and that's 36. So that means 5/6 is going to be a larger fraction, because when I compare 40 and 36, 40 is a larger number. I can also do the same thing over here, though, and I should get the same answer. Do the same to the bottom and the top. And again, 20 is larger than 18, so my 5/6 fraction is going to be my larger fraction. Okay? There's one other trick, though, to comparing fractions, and this one's a pretty simple trick, and I'm going to talk to you guys about a method called cross-multiplying. And actually, cross-multiplying, I'm going to show you where it comes from, or how you come up with it, and where these numbers come from, and why it works this way. Okay, cross-multiplying, when you compare fractions, it's very easy. All you have to do is compare the denominator and the numerator of each of the fractions. So I cross-multiply. It's kind of like making an X. So here I have 8 and 6, and 8 and 5. So 6 times 6 is 36. 8 times 5 is 40. Since 40 is a larger number. Okay, sorry for that interruption there. So since 40 is a larger number than 36, and I know that 5/6 is the larger fraction. So where does this strategy come from, or like how does this work? Well, let's think back to when we were just comparing fractions and we found the common denominator of 48. Okay, and so you guys know whenever we just multiply the denominators, 6 times 8 is 48. All I'm doing is I'm multiplying this denominator by this denominator, which is times 8, to get 48. So that means there's that 6 times 8 is 40, and 8 times 6, the other denominator right here, is 36. Well, if you look at these comparisons here, that's all that I'm doing. Okay, these two numbers, 40 48 and 36 48, that's like doing this. That's all that is. And so it's just multiplying with the number across, and then you're making your comparison. So so real quick, since cross multiplying is a fast method of comparing fractions, let's take a look at another example. If I wanted to figure out the differences or compare the size of two fractions, like let's say I wanted to do 1/8 and 2/7. Okay, both of those are pretty small fractions, and I want to compare the size of them. So what I'm going to do, this cross multiplying method, and remember that the number you multiply by, so like 8 times 2, my result is 16. That goes with the numerator that I multiplied with. Okay, so I'm going to put the 16 here by the 2 because I used this numerator. Okay, and then 7 times 1 is 7. So now 7 and 16 are the numbers I'm comparing. 16 is larger, so that means 2/7 is my larger fraction. And so I'm going to use that symbol to compare them. Okay, so that was your last quick tip on multiplying and comparing fractions using the cross multiplying method. Remember that the other way that you can do them is first by just using common sense, looking at two fractions and just using your sensibility of, oh hey, 1/3 is a pretty small fraction, 7/8 is almost a whole, so I know that 7/8 is going to be my larger fraction. So you can just use number sense. But then the other way that you can use that, you can also use to compare fractions, is finding a common denominator, and we did that a lot with adding and subtracting fractions. But then a quick method is using a cross multiplication method. Okay? So please ask if you have any questions.